You know, our entire digital world, everything from the AI we're all talking about to just streaming your favorite show, it runs on machines that get incredibly, incredibly hot. We spend billions, literally billions, just trying to cool them down here on Earth. But what if we've been looking in the wrong place? What if we moved our most powerful computers to a place where cooling is just effortless, infinite, and totally free? Okay, let's get into it.
So that's the number. That's the baseline temperature of deep space. We're talking minus 270 degrees Celsius. I mean, it's not just cold, it's almost absolute zero. That's the coldest it is physically possible to get. It's an environment more extreme than anything we can really wrap our heads around.
So that leads to a pretty wild thought, right? Down here, we are fighting this constant, expensive battle against heat. So what if we just stopped fighting? What if we went somewhere that has already perfected gold?
And that's the heart of what we're talking about today. The idea that the future of computing isn't here on Earth, but out there, using the perfect, permanent cold of the universe to unleash a whole new generation of processing power.
Okay, before we get too far out there, let's ground ourselves in why this is even necessary. The problem we're trying to solve is huge, and it's getting worse. Our data infrastructure, well, it's hitting a wall, both physically and environmentally.
And this really puts it in perspective. Take a look at this chart. Almost 40%, sometimes even more, of the money it takes to run a data center on Earth isn't for computing. Nope, it's for air conditioning. It's just a massive energy suck, all dedicated to fighting a fire it started itself.
And yeah, the costs go way beyond money. These things drink millions of gallons of water every single day. They put a huge strain on local power grids. And get this, during a heat wave, they can be forced to shut down. That's the exact time we're all cranking up our own AC and using more data. We are literally running out of land, water, and power for this stuff.
All right, so the problem is clearly heat. The solution? We need the ultimate radiator, the ultimate heat sink. And it turns out the universe provides the perfect one, for free.
See, space isn't just an empty, cold nothingness. That temperature, that minus 270 degrees Celsius, is actually a fundamental property of the universe. It's the cosmic microwave background, basically the faint, leftover heat from the Big Bang itself. It is a constant, totally predictable, and unbelievably powerful resource for cooling. And the physics of it is so elegant. Here on Earth, air actually traps heat. But in the vacuum of space, there's no air. So heat can only escape through one process: radiation. An orbital data center would just have these big, passive radiator panels, kind of like wings, and they would just radiate all that waste heat straight out into the void. That's it. No pumps, no water, no fans. It's just simple, beautiful physics at work.
This comparison here just says it all, doesn't it? I mean, just look. On Earth, we're in a constant battle with physics. Air traps heat. Weather is unpredictable. Gravity limits how we can build. And land, water, power, they all cost a fortune. But now, look at this space column. Suddenly, physics is on our side. The vacuum is a perfect insulator. There's no weather, so you get incredible reliability. And the two most important resources, sunlight for power and the cold of space for cooling, are absolutely 100% free.
I know. This probably sounds like something straight out of a sci-fi movie. But the path to actually building these things in orbit is getting more and more realistic. So how would we pull it off?
Well, you'd start by launching these compact, modular cubes. Think of them like cosmic Legos. Then, once they're up in orbit, autonomous robots would get to work, assembling everything in microgravity. They'd unfold these vast solar arrays for nonstop power from the sun, and then deploy those huge radiator wings for that effortless cooling. It's all robotic, clean, and incredibly elegant.
And here's the real kicker. This isn't just about saving a few bucks on the electric bill. It's about raw performance. See, heat is the #1 enemy of a computer chip. It's the main bottleneck. If you get rid of the heat problem entirely, you can run chips way faster, you can pack servers much closer together, and you can absolutely supercharge the massive AI models that are shaping our future.
Okay, but the big question is always, what about the lag? What about latency, right? Well, the time it takes for a signal to go up to low Earth orbit and back down is about 20 to 40 milliseconds. And that is actually about the same as sending data from one side of the US to the other through fiber optic cables. For the heavy-duty AI training we're talking about, where the amount of data, the bandwidth, is the real bottleneck, that delay is totally manageable. Orbit is a surprisingly realistic place for this.
So the performance boost is amazing.
For sure. But the real driver behind this whole idea, well, it comes down to an economic and resource equation that's just impossible to ignore. This quote just nails it, doesn't it? Cold is performance, vacuum is efficiency, space is the perfect data center. Every single one of those physical properties of space translates directly into a huge advantage. Cold gives you performance, the vacuum gives you efficiency. It's not just a good spot for a data center, it's the perfect spot.
Okay, so let's really drill down on the economics of this. We're not talking about trimming the budget here and there. We're talking about taking the biggest operational costs of a data center on Earth, the land, the water, the electricity for cooling, all the maintenance, and just deleting them. In orbit, those costs don't just go down, they go to zero. The entire model flips. Instead of a never-ending bill for resources, it becomes a one-time cost to build and launch. And with reusable rockets, that cost is plummeting year after year.
But this is where the story gets even bigger. The economics are so good, it's not just about making our current internet more efficient. It actually unlocks a much, much grander vision. This tech isn't the end goal, it's the first step, the foundation for a permanent industrial infrastructure across the entire solar system.
Yeah, this isn't just about moving our servers a few hundred miles up. This is about a fundamental shift in what it means to be human. It's about going from being a species stuck on one planet to one that truly builds and lives and works out there.
And this incredible future relies on three key technologies coming together. First, you've got something called a diamond shield. Now, it's not actual diamond, but a super strong, ultralight carbon material that protects against radiation and heat. Second, you have the Nuclear Starship, which is basically a compact nuclear reactor for power and propulsion anywhere in deep space. And third, the quantum data center, which uses those near absolute zero temperatures to finally unleash the full power of quantum computing.
And this is where it gets really mind-bending. These aren't just individual, lonely satellites. Remember those Lego blocks? They're designed to connect. Multiple starships can dock and lock together, forming this massive, expandable, mobile megastructure. It's basically a self-sustaining industrial asset, a kind of mobile base that can go anywhere it's needed in the solar system.
So what does this thing do? Well, it's not just one thing. It's the ultimate data center, sure, but it's also a deep space research platform. It's a communications router for the entire solar system. And maybe most importantly, it's the mobile forward operating base for humanity's expansion to the Moon, Mars, and beyond.
So it really leaves you with one final thought. If the universe itself is the perfect data center, offering up free power and free cooling, then the only thing holding us back is our own imagination. The question isn't really if we can do this anymore. The real question is, what are we going to build with it?